Hello, this is the last video of this lecture, and in this video we will study joint distribution and marginal distribution. They sound difficult, but actually nothing special. Joint probability distribution is probability distribution of multiple variables. For example, the previous example of female health insurance is a joint probability distribution. We considered two variables at the same time and their probabilities. And as opposed to the joint probability distribution, if the probability distribution is about a single variable, we call this the marginal probability. A marginal probability is either from our example, if you only look at the probability of female, this is about only one variable. You don't care about the other one, then it is the marginal probability. And probability of health insurance is also another marginal probability. So the joint probability and the marginal probability is about the number of variables involved in the probability distribution, right? And then what's interesting, then we are going to study the relationship between the joint distribution and the marginal distribution. First, calculating the marginal distributions from the joint distribution is straightforward. So for example, you have this 2 by 2 probability distribution. And if you would like to erase, so if you are interested only in health insurance variable, you can simply sum through a row, sum by row. Then the first row has 33% and second row has 66%, which makes the marginal distribution for health insurance. We already made this probability distribution earlier in an earlier video. Exactly, this is what we get from these summations, right? So summation through a row means you are deleting information about gender. You sum all the probabilities in the same row regardless of their gender. So gender information is gone, it disappears in the sum. And you may do the same thing by summing vertically. If you sum by column by column, then you get the other marginal distribution. It's a marginal distribution for gender variable, say 50% and 49%. So again, the idea is the same. When you add the probabilities of females who do not have health insurance and those who have health insurance, by summing them, you delete the information about health coverage. Deleting, when you have information, deleting on information is pretty simple. It's always possible. Deleting on information is possible, but what I'm going to show you here is the other way is not possible, because deleting information is possible, but making up a new information is not possible from the data. So these two marginal distributions, you may think those two marginal distributions are complete information, complete summary of the data, at least for these two variables, but actually they are not. The marginal distributions do not contain the full information as in the joint distribution. Let me show you why they are not the same. So suppose that you know those marginal distributions. So you know 33% do not have insurance and 50% are female. From these two numbers, from these two probabilities, can you calculate the probability of female not having on health insurance? Think about this. Can you calculate this? if you have answered, I'll turn the page. The answer is no. No, you do not know exactly how many female do not have health insurance, because I'll show you two different examples. So the numbers, you have marginal distributions. So you know these numbers, you know these numbers, but we are interested in probability in here, right? So excuse me. So without changing those marginal distributions, marginal probabilities, you may change this number like this. So for example, from the same number, you can arbitrarily change it to 0. If you want to make it 10%, you can do that. So it is possible to change this number without affecting the same, affecting the marginal distributions. Therefore, even if you know the marginal distributions, we cannot tell what is the true joint distribution. If you did not know those numbers, these numbers cannot recover the 2x2 table. That's a big problem, and a lot of people misunderstand this problem. So the joint distribution is much better, contains much more information than marginal distributions. So try to obtain joint distribution if you are handling multiple variables. And let's put it more abstract way. You may consider this problem, approach to that same problem mathematically, like considering, so we are looking for those four unknowns. We would like to recover the full probability distribution table, which is the joint probability, but the information we have is the marginal distributions. That is, we know the horizontal sum is 33%, and vertical sum is 50%, right? And then, of course, if you know x plus y is 33%, z plus w will be easy to calculate. It's 100% minus 33%. So the probability of not covered is 33%. So then automatically, probability of the covered is 66%, right? So z plus w is implied by this equation. Mathematically, they are the same. And similarly, if you know the probability of female, then probability of male is automatically known, right? 100% minus female probability is the male probability. And then anyhow, so this probability, the probability of male and the probability of the covered, do not provide additional information to solve for those unknowns. And then we have 4 unknowns but only 2 equations, so we cannot solve it. That's this is the mathematical approach. Then how can we answer those questions? Like, but if we have one more information, suppose that, so the first 2 informations are the same as marginal distribution. So we know the marginal distributions, and in addition, we know another probability, which is outside of the marginal distributions. Then from these 3 informations, can you calculate the probability of female without health insurance? The question is the same as before. I only added another information. Can you calculate? Think about this. If you think yes, try to calculate the probability. The answer is actually yes. The answer is yes, and I will make it another mathematical problem. So the unknowns set up in the same way, x, y, z, w, and the three informations we have can be written in this way. The third information is the probability of male without health insurance, which is y. We know y is 19.89%. So then you may think we have three informations, but we have four unknowns. Then it cannot be solved. But actually, there is another hidden information from the fundamental property of the probability, which is this. The sum of the unknowns must be 100% all the time because they are probabilities. Probabilities must sum to 100%. Then now you are done. You have four equations, four unknowns, so you can solve for them. I will just simply show you how to do this. Say y is 19.89%, and you know y, so we know y. Then from number 1, x can be written as 33 minus y. You can calculate that because y is known. Now x is known, y and x are known. So from number 2, x is known, right hand side is known, so z is known. Z is 50 minus x. So z is known. Then x is known, y is known, z is known. W is known now. W can be recovered. So you can calculate, you can solve for everything. So what I'm telling you here is this information is what's missing from the marginal distribution. You need to know probability of at least one outcome. So which is the relationship between these two. So this probability is related to both events, female and healthy insurance. You need to have at least one information like that. That's the correlation between two events. Otherwise, the marginal distributions are not as complete as the joint distribution. That is the conclusion of this part. Okay, so and then once you fully recover the table, calculating the probability is also straightforward. So the answer is yes, you can calculate any probability. Okay, this is it. I am going to post the first homework, which is due September 26th or something. I'm recording this video on August 25th, so you have about a month to do the homework. And also I posted a practice homework, so try that to see how it works. And as I said, in doing the homework, you may use any program, calculator, or like anything. But I want you to, of course, you have to do it by yourself. And the numbers are randomized, so you can repeat. If you repeat the homework several times, you can try up to 10 times, and then each time the numbers will be randomized. So good luck. If you have any questions, let me know. Stop by the office hours if you have questions. Thank you. See you later.